Thank you for joining us today. In this session, we're going to be discussing the basics of combustible dust. Please know as we move through this webinar that's for informational purposes only and does not constitute any legal or commercial advice. And with that, we'll talk a little bit about the session here and introduce everyone. My name is John Danio. I lead our corporate efforts here supporting engineering firms at Donaldson Company. We also have Amy Miller on with us today. She's our training manager. She'll be working behind the scenes throughout the webinar and will help answer with the Q&A at the end.
Thanks for joining us today. We usually have a ton of questions for this particular topic, so Chrissy will be ready for that. But yeah, as you think of questions during the webinar, make sure and chat them in whenever it comes to mind, and we'll address them towards the end of the session.
All right. Yeah, thanks, Amy. So the purpose of today's webinar is to answer your questions around combustible dust. We'll talk about how combustible dust impacts industrial ventilation system design. We'll also be reviewing some mitigation options, and then we're going to discuss how you as an engineer can help your customers. So in case anyone isn't familiar with Donaldson Company, we've been solving customers' complex filtration challenges for over 100 years. We were founded in 1915 by Frank Donaldson Sr., who invented the world's first filter for a tractor engine. Today, we're one of the largest providers of unique filtration technologies, and we excel at producing high-quality filters and equipment. We pride ourselves on having a global reach with a local touch. Our world headquarters is here in Bloomington, Minnesota, but we have about 54 manufacturing plants around the world and 23 distribution centers. And with that, I'm pleased to introduce our featured speaker today, Christy Clocker, who's a senior engineering manager here at Donaldson. She has an engineering degree from North Dakota State and a master's from University of St. Thomas. She's been with Donaldson for over 15 years in various engineering leadership roles. She's actively involved in the industrial ventilation committees and organizations, including the Michigan IVC. And I think you'd be hard pressed to find anybody who has more knowledge around managing combustible dust than Chrissy. So with that, Chrissy, you can take it away.
All right, thank you, John. Sound check, everything sounds okay?
Yep.
All right, great. Thank you everyone for joining us today. This really is an important topic, and even just building awareness, learning more about it, learning different perspectives is really important to everyone on this call and to our customers and end users out there managing combustible dust. So I'd like to start out today by just asking you to quickly rate your combustible dust knowledge on a scale of 1 to 10. 1 meaning maybe you've heard of combustible dust, but you don't really know much about it. You're kind of new to the topic. 10 being you want to present this next time for us. So if you can just go ahead and kind of chat in your what you think, that'd be really great.
All right, looks like I'm seeing 1 through 5, so a couple 6 and 7. So it looks like you got a fair range from little knowledge to a fair amount of knowledge.
Excellent.
No experts yet, but that's what people are hoping to get out of this meeting.
That's okay. It's definitely a topic that I myself am constantly learning about, even just talking about it with other people, those who are even kind of on the 5, 6, 7 range. You're always going to find something new that's going to give you a different approach or a different way to think through combustible dust. And so again, thanks for joining us today. I hope you at least learned something. So I just want to provide a little bit of context. Going back, facilities have always been generating dust. It's part of manufacturing. It's part of why we're here today. And so in 2003, there were 2 very important events that took place, Hayes Lemurs and West Pharmaceutical. And these 2 events were catastrophic in terms of the damage that they created. And you can see in the pictures below that it's not taken lightly. And so it was from those 2 events that OSHA created this national emphasis program, and they started looking at combustible dust in industries that create combustible dust as part of their manufacturing process. In 2007, they released the national emphasis program, and they highlighted some of those industries. Food, ironically, was not one of them. And the following year, there was the Imperial Sugar event. Imperial Sugar is kind of a very well-known catastrophic combustible dust damage. And that revised then the national emphasis program. They added food and they added additional industries. Since 2008, there really wasn't much change to the national emphasis program, besides the creation of the NFPA standards and then ongoing updates to those standards. And throughout it all, combustible dust events continue to happen, right? They had, in 2015, there was a massive flash fire in Taiwan, and events happened both locally in the US and as well as worldwide. Didion Milling was one that was in Wisconsin in 2017. And so in 2023, OSHA revised their national emphasis program again. And what this meant was they just broadened even more industries that could involve combustible dust as part of their manufacturing process, and a way to kind of reignite this emphasis on combustible dust. Now, one of the great things about all of these events is we can learn from all of them, and hopefully that's what we're going to do today, is talk through them. But it is an event. It is something that happens every day, and it continues to happen. And so by building awareness, by learning about this topic, hopefully we can kind of help reduce some of those next significant and major fatalities from happening in the future. So we talk about OSHA. OSHA is in most cases a code that manufacturers will have to follow, but NFPA is what's called a standard. So in the US, we have both codes and standards. Codes are adopted by cities and states and municipalities. Famous ones would be the International Fire Code or the International Mechanical Code. Standards, however, are not typically adopted. So NFPA is a standard. It is written like a code so that if it is adopted, the language is right there, but unless it's adopted, it's not actually enforceable. Other standards would be Factory Mutual. They are an insurance provider and they have their own written standards for how they handle and manage combustible dust incidences. This is what NFPA standards look like. These are most commonly used in the combustible dust realm. NFPA 660 was created last year, or kind of end of 2024, and it's a culmination of all of the previous industry-specific standards for combustible dust. So you may have heard of 652, that was prior, the standard on fundamentals of combustible dust, as well as 44 for metals, 61 for grain, or 61 for ag, 664 for wood. Those were all put together into one giant standard, NFPA 660. It provides guidance quickly for kind of your generic guidance, doing your DHA, management of change efforts, all of that, as well as industry-specific standards. The reason why they did that is because they found that processes and manufacturing facilities around the world didn't actually just use one type of material. They often found themselves maybe using wood and the general standard, or using grain and wood as within their facility. And so by having everything in one place, it provides easy access to all process owners to see the differences in how the mitigation strategies are approached. In addition to 660, we will often reference 68 and 69 for mitigation strategies such as deflagration venting and explosion prevention systems like isolation, as well as 77, which would be your bonding and grounding and static electricity procedures, and then 91, which is looking more at your industrial ventilation systems. 660 is going to take some time for people to adopt this, and so you will still see reference to other ones. I encourage you to go on to nfpa.org if you have any questions. All of the standards can be accessed for free. You can also purchase copies if you want to have, you can mark them up and reference them as you'd like. So besides attending trainings like this, what can you do to help familiarize yourself with combustible dust? And the first step is to just get awareness of NFPA. Awareness of this, familiarize yourself with combustible dust hazards, with the type of materials you're looking at, ask about local codes, ask about FM Global if that is appropriate for you. Otherwise, familiarize yourself with the NFPA standards. Awareness is going to help increase our mitigation strategy, which is hopefully going to produce better results going forward as we continue to grow in the manufacturing industry. And please ask questions. Amy mentioned that before. Type them into the chat. I will definitely leave plenty of time to answer questions. So there's three main combustible dust hazards that we deal with. These fine particulates will change based on either the manufacturing process, the type of products that are produced. But in general, the fine particulates do present three types of hazards: a fire, which is a fuel source, that's your combustible dust; oxygen, usually a system will have air pulling it through; and an ignition source. If those particles are dispersed in the air, that dispersion creates a flash fire risk. That's the square that's in the middle. And if all of that is going on within a confined space, that creates the fifth potential, that confinement. That is your explosion pentagon, which is on the right. So it's important to address these risks throughout the whole life of the process. So looking at different scenarios, how does your risk profile change if it's at startup, if it's at normal operation, and if it's at upset conditions, right? Based on when we're using our products, we want to understand what are the potential hazards that we could come across really at any given time. So why dust collectors? Well, we collect dust. That's what we do. So if we are managing and collecting a combustible dust, that creates the fuel within our environment. During normal operation, our filters will often pulse clean using compressed air, and that pulse is what disperses that finely divided particulate into, the environment. We, in most cases, will have a fan that's moving air from point A to point B, so that's creating oxygen within the system. The dust collector housing creates a confined space, right? All of this is happening within a dust collector housing. What we don't provide is an ignition source. Ignition sources will come externally, just like the fuel is brought into the collector. Ignition sources can also be brought into the process. And so because we have potential for all five of these, fuel, dispersion, oxygen, confinement, and ignition sources, to be present, dust collectors need to be they are a very critical part of an overall mitigation strategy. So what if you don't know if their dust is combustible? Usually if you're working with an engineering firm or you have a brand new facility that you're building, you don't have dust to get tested. And so you may not know if it's combustible or not. If you do, the quick answer is you should get it tested. If we don't have that dust, we'll talk a little bit about how we can kind of get some insight into the potential if that dust is going to be combustible or not. So when it comes to combustible dust testing, we want to make sure we understand what's in the airstream. The easy one is if it's a dust, right? We can get dust tested, and there's parties and third-party companies out there that will do combustible dust testing. And the two main ones are going to be testing for a KST and a Pmax value. These are going to give you an indication of how explosive these materials are going to be. Higher explosivity levels will mean you need mitigation strategies that are going to react faster than lower KST or Pmax values. In addition to KST and Pmax, things like minimum ignition energy. So, how sensitive is that dust to an ignition source? That might be important, especially if you have a dust that has a very low sensitivity value. Things like bonding and grounding or media choices might be really important to that strategy. Minimum explosible concentration, that is looking at, do you have a sufficient quantity of dust to even create the environment for having an explosion? Within the dust collector, usually when you're collecting dust, yes, we do have that. So it's not really a strategy of saying, I'm going to clean my dust collector really well, and therefore I don't have an event. Not really a strategy we recommend. If you also are dealing with any gases, VOCs, or other contaminants that could come through, there's also testing such as your lower flammable limit. Those are a little bit more challenging, and again, maybe not known at the beginning of a process, but it is important to recognize if you do have them, we do have testing methods available to help indicate additional hazards that might be present within the system. So this is one of my favorite charts, and it kind of helps explain all of the different pressure related terms as they relate to combustible dust. So what you're seeing on the screen is a graph of the pressure wave during a deflagration. So the little lightning bolt there, that's our ignition source. And what you can see is this red line is going to escalate very quickly. The highest value that that pressure is going to achieve is called your P max value. This is the maximum pressure reached in a contained deflagration. So that P max value is usually in the term realm of about 8 to 10, maybe up to 12 bar. That's usually what we're seeing. That P max value is not going to be something we want to try and contain. It doesn't make sense to build your dust collector so that it withstands the P max value. And so what we want to do is incorporate kind of a predetermined weak point in the collector to let that pressure out of the vessel. That weak point is going to be an explosion vent. An explosion vent is specifically designed to open at a significantly lower pressure. We're talking 0.1 bar for those of you who like your numbers. And that explosion vent is going to open far before we can even reach that P max value. Now, as that explosion vent opens, that pressure wave is growing so quickly that not all of the pressure can be released at one time. So you still will have this growing pressure rise that's going to be created within the vessel, and then it's all going to exit through that opening of the explosion vent. That growing pressure, that residual pressure, that is called your P red value. This is a calculated value, and it's based on the volume of the vessel, the type of dust that you're collecting, the size and quantity of the explosion vent, and a lot of other factors. And what we want to make sure is that the enclosure strength of the collector, the rated P red value of the collector, is above that residual P red value, right? We want to make sure that nothing else is going to open or cause issues, that all of that pressure is going to be released through those explosion vent openings at one time. The slope of this line is your KST value. It's your rate of pressure rise over time. And this KST value, like I said, is going to be anywhere from 1 to 300, 400, 500 bar meters per second. So it can really vary based on the type of material that you've got, but it's basically going to indicate how quickly will that dust reach that maximum pressure. If you don't have dust to test, there are other resources that you can access to get into feeling if this material is going to be combustible or not. NFPA.org/660 in the annex, they have information on common dust materials for agriculture, chemical, metal, and plastic industries. They'll list generic KST values, MIE values, and other information. In addition to this, Justice is a database of dust testing characteristics. You can follow this link or just Google Justice Dust Database, and it'll take you to a searchable function where you can identify, this is the material I'm looking for. And on the right-hand side example, we searched wood flour, and you can see that they have different values where someone at some point identified this material as being combustible, and they're going to give you a range of explosivity, ST1, ST2, ST3. Now, this information is going to correlate to a general KST value. So an ST1 dust is something that's less than a KST of 200. An ST2 is between 200 and 300, and an ST3 is anything greater than 300. Again, even though it says weak explosion or a strong explosion, this doesn't mean that you're going to not have damage. Any type of combustible dust event has the potential to create damage within your facility. And so we want to make sure they're mitigated appropriately. The reason why we ask for KST values is because depending on the value, that will change the mitigation strategy that you use to minimize and reduce those risks from happening. So, how does combustible dust impact an industrial ventilation system? Well, this is a great slide. As you can see on this slide here, we have industrial ventilation systems are made up of multiple components. You have a hood, and that hood is designed to capture particulate from the process. Once it gets into the hood, it's conveyed through a series of ducts to a filtration device or a dust collector. Clean air will pass through the media, and the media captures the dirty air, those particulate and fibers, and it'll pulse them off into a discharge device. Clean air will go through the media and discharge out through a fan. So as you go through and look at this, part of the industrial ventilation system and the design of the system is really important. We want to make sure the combustible particulate is captured appropriately. It's conveyed at an adequate velocity to get from point A to point B. It's filtered it's filtered appropriately, right? We have the right media, we know what the contaminant is, and then it's, you've got clean air that is either returned back into the building or exhausted to an outside atmosphere. Depending on mitigation choices, where the collector is located, there's a lot of design factors that are going to go into the system. You also have the risk of people modifying the system. How would the addition of a new process impact the strategy? Looking at, does that throw off airflows in one system? Does it add new contaminants? That's going to be part of a management of change practice that the process owners will want to consider. So we use the industrial ventilation manual for sizing dust collection systems. And this year they actually added a new hazard management section into it, and really kind of addressing their role in designing industrial ventilation systems as part of an overall mitigation strategy. 660 also added information in theirs that says, hey, we need to design the system so that we have adequate velocities to capture, control, and contain the dust. We want to make sure we've got good pickup points and velocities within our duct system. And for that, they will also reference users to the ACJH Industrial Ventilation Manual. So depending on the dust that you are collecting, we want to look at different conveying velocities within the system. All of these conveying velocities will impact the static pressure of the system. It might impact changes to the duct size, changes to airflow, which then might impact changes to the fan horsepower or other things. If you don't have enough velocity to convey the material, the result would be material settling out in your ductwork. So we want to avoid that at all costs. Designing systems to, make sure that we're maintaining the minimum level, the minimum velocity at all times, even if there are challenges or unknown factors once the system is installed. We also want to minimize obstructions in the ducting. We recommend using a balance by design approach rather than blast gates, because blast gates can create a potential for material to build up within the ductwork. You also want to have clean out doors appropriately spaced throughout the ductwork so that you can do a visual check to make sure that nothing is settling out in your ductwork. If possible, using controls like VFDs and airflow controllers to kind of maintain or at least indicate if you have a reduction in airflow, as that could lead to an increased potential for a hazard such as dust or material settling out in your ductwork. One of the big questions is returning air to a building or exhausting it outside. This is a great question and I get it all the time. The answer is it's really going to depend on the type of material that you're collecting. I think we might address this later on again in the presentation, but if you do decide to return air to the outside environment, just know that NFPA often requires additional mitigation equipment, such as a safety filter or some means of detecting if there's a breach in the primary filters. Also, they recommend having a way to divert air to the outside atmosphere if there is a fire or something else going on within the system. So if we know the dust and the airflow, we can start looking at the right technology for what we've got going on. There's a lot of different dust collection technology out there. We've got cartridge style and baghouse style. Those are your more traditional value styles. We also have wet collectors and enclosureless collectors, even some intermittent shaker style collectors out there. A lot of these can handle various mitigation strategies. So explosion vents, chemical suppression, flameless vents, no mitigation. It really just depends on, we want to make sure we've got the right technology to filter the contaminant, and then looking at how do we support this with the mitigation strategy. So traditional cartridge and baghouse collectors are quite easy, actually. They can be used with a variety of mitigation strategies. They can be indoors, they can be outdoors, they can, work across various industries and applications. When we get into specialty collectors, this is an enclosureless dust collector. And like the name says, it does not have an enclosure. So these can be located indoors according to NFPA without explosion protection. And the reason for that is if you think back to those 5 Pentagon requirements, right? We had fuel, we would still have fuel. You would have a potential for an ignition source. You would have airflow or oxygen moving. You've got a fan. You would have dispersion potentially, depending on how the system works, but you don't have the confinement. That's your enclosureless system. So without that, you don't have the risk of an explosion per se, but you do still have the risk of a fire and a flash fire because you have everything else in your system. And so these are sometimes a strategy that intermittent processes will adopt. They are limited by airflow and by application. So if this looks like a potential option for you, I suggest reaching out and getting some more information on how it can potentially be a strategy for you. The other one is a wet collector. NFPA 660 in the metals section often recommends using one of these to help mitigate the effects of a fire or explosion. It's really important that you pay attention to material compatibility so we don't have any sort of off-gassing or other issues created by this. Wet collectors are a different technology than your traditional cartridge and bag houses. So it's important that you look at all sort of system requirements from, installation and maintenance compared to other types of technology. NFPA really wants you to have the collector outdoors, as does OSHA. They always recommend that. If you've got a collector volume greater than 8 cubic feet, it shall be located outside of a building. However, if it's properly protected for fire and explosion risks, it could be allowed in. If it has a dirtier volume less than 8 cubic feet, if it's a wet material, if it's a wet collector or an enclosureless collector, those are allowed to be indoors. When in doubt, put the collector outside. The exemption for small collectors less than 8 cubic feet is not due to there's no risk, right? Just because you use a small vessel to collect the material doesn't mean that that small vessel changes the characteristics of the dust and it's no longer combustible. That's not true. Your dust is still combustible. It doesn't matter what you collect it in. The requirement for less than 8 cubic feet comes in play because it is physically hard to mitigate a small vessel. 8 cubic feet is 2 feet by 2 feet by 2 feet. And it's really challenging to put an explosion vent on a small vessel like this. And so those strategies become very impractical, and that's why it's in here. The standard is more for little small vacuum systems, and for those you will find specifically designed NFPA compliant vacuum systems. If you choose to go this route, NFPA recommends that during your DHA, your dust hazard analysis, that you look at the potential consequences of a fireball. So if something happened, they recommend looking at 8 times the volume. So 8 times 8 is 64 cubic feet in volume. And so if your device is sitting on the floor, this would be a sphere with a radius of 5 feet in all directions. And it's important to look at, based on where this device is located, what is potentially in the area that could get harmed if something were to happen. NFPA gives guidance on central versus dedicated systems. Their big thing is not mixing contaminants. So if you have a wood shop where you've got saws and lathes and sanders, it's all wood dust. It's just in different shapes and forms depending on the process that's creating the dust. All of that dust can be brought to one collector to be filtered out. That's called a manifolded system. If you had a job shop and you had different lasers that cut aluminum and carbon steel and stainless steel, then you would want to have dedicated collectors for each specific application. And the reason for that is if you were to bring all of those metals to one collector, mixing those metals could create the risk of a thermite reaction. So looking at the operation and the different contaminants that you're generating is really important in terms of figuring out what type of even just dust collection strategy you're going to go with. For media, NFPA 660 says it has to be constructed of combustible material. Most traditional dust collection systems are. Filter medias are cellulose or polyester. And you'll see that across all of the industry. We want to make sure that all things are conductive, so not using ductwork that's made out of PVC pipe, but we want to make sure that we're using metal duct and it's all bonded and grounded. Anytime we've got a combustible dust, bonding and grounding practices are advised, and that's just to make sure we don't have any isolated components within our systems. On the page here, you can see we have different media options as well that could support your mitigation strategy. If it comes to cartridge technology, we have FR media, which is media coated with a flame retardant coating that helps reduce a filter. It self extinguishes the fire as long as the ignition source is removed. We also have conductive media options for cartridges, as well as what you see for felt bags. We have epitropic or anti-static media, as well as media that can have a ground wire in it. That ground wire is used to bond together the inner cage with the tube sheet so that we don't have those isolated components. In all of this, we also want to pay attention to the configuration of the dust collector. A lot of mitigation strategies are impacted by volume and height, such as explosion vent sizing. They look at those features of the vessel itself. So if you have a tall and skinny vessel, it could be more challenging to mitigate or provide enough vent area compared to a shorter and wider collector. This will also impact discharge devices and other options and features within your collector. All right. So what are some typical mitigation options? Well, there are a lot of manufacturers out there, and they all have very similar versions of the same device. And so it's really important that we pay attention to the different high-level things, but always ask questions to those suppliers to make sure that you're choosing the right device. But we'll go through a couple of them. So NFPA 660 has a new method for complying to the NFPA standards. So this section is new. It was rewritten when they created NFPA 660. For those of you who have attended these webinars before, you might have seen a simplified version of this page where it was either a prescriptive requirement or a performance-based requirement. Simple. Now what NFPA is saying is you actually have to do two things. In addition to either using mitigation strategies that are followed by a prescriptive requirement or a performance-based requirement, you have to follow the prescriptive methods outlined in chapters 5, 7, and 8 of NFPA 660. These chapters cover your dust hazard analysis and your management systems. So things like doing your DHA, and then once you've done your DHA, identifying hot work practices, training for your employees, training for contractors, preventative maintenance schedules, identifying near misses, and all of these other things that most facilities are already tracking. Those things go into your mitigation strategy because training employees, identifying near misses, all of that helps to make sure that if something goes wrong, either we have the right technologies in place, we modify our systems, and our people know what to do. So DHA and management of systems are now a requirement. In addition to that, it is mitigating your strategy according to prescriptive methods or performance-based strategies. In most cases, facilities are going to use both of those. For example, a prescriptive method might be sizing an explosion vent. You follow the calculations in NFPA, you figure out how much vent area you need. That is a prescriptive requirement. A performance-based strategy might be, we're going to put the collector outside, and instead of using a rotary airlock, we're going to just use a standard drum cover, and we're going to assess the area around it as part of the DHA to make sure that there's no increased risk for making that decision. So when it comes to mitigation solutions, there are different techniques and equipment for each scenario. Even if you have a sister facility in one state and you're in another, you're going to potentially have a different risk scenario. We want to make sure you choose strategies that meet the needs of your process and your dust hazards. And then you also look at different or associated system components. Some of these systems, such as a flow actuated isolation valve, a flameless vent, knife gates, chemical suppression systems, they all have to be tied to a device that can shut down the fan. So if you don't have that integration with the control panel, the product might work, but the next steps of what happens in that sequence of events may not follow through. When it comes to fire prevention, there are different strategies. We've got active spark abatement. That is looking at a spark detection and extinguishing system or a detection and abort system. There's passive devices that will go in line in the ductwork. And then you can also choose to have an inerting agent, such as adding lime or something to render the material non-combustible or non-flammable. For secondary events, we have abort gates. That's going to stop smoke from getting back into your facility if you choose to return the air. When it comes to fire protection, we have wet and dry sprinkler systems, CO2 and argon. The biggest thing on this page is making sure you're using a material that's compatible with what you're collecting. If you're collecting aluminum, using water or a sprinkler system to suppress a fire is not going to work. You need to make sure you have a material that's going to be compatible with putting out an aluminum fire. For explosion prevention, again, we've got the same for ignition sources from the primary event. That ignition source, right, was involved in fire, flash fire, and explosions. So if we can reduce those ignition sources from getting into the system, we're reducing the likelihood of all of those different hazards. So same events, spark abatement and inerting agents. But what we add on to for an explosion is your secondary event. This is really critical. Inlet isolation is very important because what it's going to do is stop that pressure wave and that flame from traveling back upstream into the facility. If you think back to all of those images of Hazelmer's, West Pharmaceutical, Imperial Sugar, isolation could have maybe helped reduce some of that damage. When that flame and particulate goes back through, it disrupts any sort of fugitive dust in a building, and it's those secondary events that we want to stop from happening because those are the ones that level plants and create that catastrophic damage. So making sure you have adequate inlet isolation is very important. This can either be passive devices, such as a flap valve that will close based on a pressure wave, or it could be active systems such as a knife gate or a chemical suppressant agent. Regardless of which strategy you choose, again, you want to make sure you've got the right one that suits the dust and the material that you're collecting. That pressure wave and flame, if it happens, it's going to go in every which direction. So you also want to look at discharge devices. NFPA recommends rotary airlock. There are also performance-based strategies such as a sealed drum kit out on the market. For explosion protection, there's kind of three major ones. You've got traditional explosion vents, you have flameless vents, and then you have chemical suppression systems. Containment is another option that NFPA looks at. That's where you build the vessel to be stronger than the Pmax value. Again, it's really not appropriate for most dust collection applications. So factors to consider, obviously the contaminant, right? We want to make sure we're using materials and devices that are compatible with what we're collecting. If it's a hybrid mixture, which is both a combustible gas and a combustible dust, please work with your mitigation suppliers to make sure you're choosing products that are appropriate. Combustible gases will be everywhere within a system. They don't just stay on the dirty side of the filters. So you want to make sure you've got protocols and practices and products in place that will be both upstream and downstream of the collector. If you're dealing with a metal dust, a lot of times these devices will have to have specific testing. Again, work with your manufacturer and make sure you've got the right testing to show that that product's going to withstand what you're collecting. Again, we've got required testing, limitations on how these products are going to be installed, and then making sure it's suitable for the material. The other one I didn't touch on quickly is just additional hazards. Some materials, if you collect them, might be non-toxic in their standard or original state. However, if that material is burnt or catches on fire or something, it could create a toxic material. This is also something to consider, as a device or a strategy that encloses that material might be more suitable than one that releases it to the environment. The dust collector location is important. The dust collectors usually can go indoors or outdoors. However, if it's indoors, it might be more challenging to mitigate. You can't just stick a collector in the middle of the room and have an explosion vent on it. That would not be a safe practice. So if it is indoors, we want to duct the explosion vent to an outside wall. You can see that in this image here. Those duct vents have to be pretty short. We want to get that material in and out as soon as possible. And then we also want to make sure we've got isolation between interconnected pieces of equipment. For the system design, if we're returning filtered air into the process or not, that might impact static pressure, fan choices, duct choices. We want to also look at hours of operation, right? An intermittent operation versus a continuous 24/7 operation might lead towards a different strategy. And then, as always, we want to make sure we involve our authority having jurisdiction. That could be a fire marshal, it could be an OSHA inspector, it could be your own internal EHS employees or legal team that help make some of these decisions. Now, I know cost is never an issue. That's what I hear all the time. But in some cases, cost is an issue. And it's really important to pay attention to that. Passive devices are usually less expensive, but you're going to be left with a mess to kind of clean up, right? If you have an explosion vent, you're going to have flame and particulate and probably residue that you're going to have to clean up within the collector itself. Active systems like CO2 for fire protection or chemical suppression are going to reduce the amount of cleanup or downtime that you have, but they're going to be more expensive and in most cases require quarterly or semi-annual checks by the mitigation supplier to make sure that their equipment is operating appropriately. So you want to look at both initial and startup costs as well as commissioning costs, and then frequency of checks going on over the life of the system, as they can add up over time. All right, so whose responsibility is it to do the DHA? Well, it's the process owner's responsibility, but they shouldn't be doing it alone. There's a lot of steps that go into doing a dust hazard analysis. You have to get informed about the dust that you're testing and the processes that are creating combustible dust. You have to assess the risks that are there. Is it a fire, a flash fire, or an explosion risk? Then we have to identify actions to reduce that risk, right? We want to get that risk out of the plant. So we install a dust collection system to remove the fugitive dust from the facility, contain it, filter it, return clean air back in. There might be other strategies, adding fire mitigation, spark mitigation, explosion mitigation, all to help identify and mitigate those hazards that you've identified. Then you got to do it. That's the hardest part. We have to execute our actions once we've identified what's potentially needed. And then we have to train our employees so if an alarm goes off, they know what to do. The fifth one is follow up. DHAs are a process. It's kind of an ongoing activity. It should be a living document as part of your management of change structure. And we'll talk about this in the next slide. Part of that is if you have any changes to your process, you're going to go back through and review. Does this impact our risk scenario? Does this change the KST of the dust? Does this change our strategy? Do we have turnover in our employees? Do we need to retrain our employees? If we have a false, either a false positive, or we have maybe a potential small little event, a fire that gets put out right away, what can we learn and what can we change as part of that strategy? This is chapter 8, your management systems, and it's going to look at how do you manage change and other processes and practices within your facility. Now, many of you are engineers who are on this call, and from a design standpoint, you may be asked for information to help support the strategy. This includes looking at the original design of the local exhaust ventilation system, looking at what goes into the choices that you're putting in there. So if you have an isolation valve, is that valve adequate for the KST of the dust that the customer has given you? Ductwork sizes, static pressure and fan choices, control integration. These are all different things that could be asked for ahead of even your project getting installed. So it's important to have that, but it's also important to give this information to your end user because they need to know how the system was designed in the first place, so that if their airflow in the system is reduced for any reason, right, they go start making changes to the system and they notice they don't have any capture velocity or, low velocity in their duct system in another section, they have something to compare it to say, okay, here's how it was originally designed. Here's the impact of the change. Now here's what we have to do. So you as engineers also play a critical role in helping customers mitigate and also continue on with updating their system as they go. Now, all of this is not done by one person. It really, truly, truly takes a team. So you've got to look at the engineers who designed the system, the suppliers and manufacturers of the various equipment components out there, the company, EHS, legal teams, your AHJs, fire marshals, OSHA inspectors, insurance underwriters, your employees, right? Ask them questions. They're a vital component to the mitigation strategy and making sure that it works correctly. And then also your third parties who come in and do your process hazard evaluation or your dust hazard analysis. So all of this is going to be a team of people that really look at what does it take to create our strategy and then implement our strategy. No one is alone, so please ask questions. And with that, I think we've got about 10 minutes. John, I think you're on mute.
I got caught. Sorry. Thank you. Thank you, Chrissy. We're going to finish up with some Q&A. Amy, if you can turn your camera back on now. Just a heads up, everyone who attended will receive an email that includes your professional development hour credit. If you don't get it within a week here, please send us a follow-up email and we'll make sure. Sometimes it winds up in the spam folder for you. So we'll make sure you get those. There's also some QR codes here if you're interested. You can see some of our upcoming webinars that we have scheduled. We also have a library of on-demand webinars from previous sessions that we've done covering different things like hoods or fans, ductwork, different applications that we have gone through and have done these hour-long webinars. So in case you aren't aware, we also have some 5-hour in-person training classes in various cities throughout the country. We've done Atlanta and Ohio already. We've got one coming up in Chicago and then another one in Minneapolis. So we're going to post a link to that if anyone's interested in a more involved 5-hour session and 5 hours of credit. We can get you that information. You can sign up and participate in that. So we will turn it over to you, Amy. What is our first question? I know we've got a few in the chat here. And again, feel free to keep entering them in, and Christy will answer as much as she can between now and the time we punch out.
Thank you, John. I did just post that link in case anyone wanted to learn about the in-person sessions. All right, Chrissy, first question. Is PRED a function of size and the number of vents?
So PRED is actually a calculated value. It's kind of a it's a calculation that results from the volume of the vessel, the number of explosion vents, or the amount of vent area that you have, and then the properties of the dust. So if you don't have enough vent area, you will have a higher PRED value that's calculated. Now, we as a company will state a PRED value for each of our dust collectors. And that PRED value is actually stating this is the maximum allowable PRED value that we can withstand in our collector. It's based on NFPA guidance, which is 2/3 of the ultimate yield or the ultimate strength of the enclosure. That's in NFPA 68. But what we're stating is all of our calculations, when we have explosion vents, that calculated PRED value must be less than what we state as our maximum PRED value. So it's a bit confusing, but it is a calculation based on vessel volume, dust characteristics, and the amount of explosion vents that you have.
Thank you, Chrissy. Next question. How would you suggest mitigating static discharge as an ignition source?
Yeah, great. Great question. Well, the first thing I would do is get your dust tested. For some materials that have a very low MIE value, so what NFPA considers low is about 30 millijoules. I like to give the recommendation of even 50 millijoules. But once you get into that less than 30 millijoules, oftentimes dust testing companies will ask you to do subsequent tests to kind of further identify what you're looking at. If it is a very low dust, they will often recommend doing a volume resistivity test. And what that helps indicate is if your dust is conductive, insulative, or not. That goes into potential ignition sources like a brush discharge, I believe it's called, which could be an issue for things like pneumatic conveying systems. So really, I would first look at dust testing. And if you have questions about the dust testing or the results, reach out to those testing companies for further help. Otherwise, bonding and grounding and the use of conductive media is really going to be kind of another layer of protection that you can have. So making sure you've got an electrician out there after they install the system, they're looking for connection between conductive components, and then making sure it's grounded or earthed to, grounded to earth for the system. Those are all really good options that I would consider.
Thank you. Next questions. Does Donaldson offer design, testing, and supply of explosion vents?
So we offer explosion vents with almost all of our collectors. Sometimes they're provided by different manufacturers. We don't manufacture our own explosion vents. We use third parties that do the design and testing of their explosion vents. All of our vents, we have a specific size, and we can tell you, okay, this collector with this size explosion vent is suitable for a KST value of X. If those boundaries are outside of what you need or not what you need, then we would work with those mitigation suppliers, the explosion vent manufacturers, to make sure we have the appropriate vent and the appropriate vent area. So things like high temperature applications or high pressure applications, or food grade applications will often dictate the use of a different vent. And then we would work with those companies to make sure we have the right product being used.
Thank you. Next question, what is a thermite reaction?
A thermite reaction is when you have two non-compatible metals. So often it's, I believe it's an oxidized and a non-oxidized metal, or even it has to do with material compatibility, but they create kind of self-explosions. And I'm sure someone on this call can explain it in the chat much better than I can. But it's where it can almost self-ignite by having those two metal reactions on each other. You can also Google videos for thermite reaction and kind of get an indication of just how quick and how explosive they are. So,
thank you. Next question, when does a dust collector require an integral fire sprinkler system? Is it an option or requirement?
yeah, great question. So, if you have the risk of an explosion, you most likely have the risk of a fire, right? So you've got 5, it's included in the 3. So it's recommended that if you're going to pay attention to explosion mitigation equipment, also pay attention to fire. All of our systems will come with like a NPT coupling or some sort of coupling that you could hook up a water sprinkler system. But again, if water is not compatible for your material, you may need to look at a CO2 or an argon system. Those are going to require different attachments, as it is connected to a series of bottles that will then flood the system. If there is an event, it'll flood it with CO2 or argon and contain that fire within the collector. So a sprinkler is just usually for most organic materials. Water is an adequate suppressant.
Is a VFD located indoors, or would it be inside the dust collector cabinet that could be located outdoors?
So a VFD is for your fan. It's variable frequency drive, and basically it's going to be integrated into the controls package. The controls can either be located outdoors or indoors, depending on where you want it. They're not located next. You don't want to put them next to the collector, but it would just be, it's part of your controls package, and it would be hooked up into your fan to vary, obviously, the frequency of your fan based on how much airflow you want to be pulling at one time.
Thank you. Next question, what do you do for a DHA when the facility hasn't even been constructed yet?
Great. I'm seeing this more and more as I work with people in the industry. We've got a lot of cities out there that are requiring what's called a design DHA. And this is a DHA that literally looks at, here's the design of my potential facility. And so there are companies out there that will do this. And what they'll do is they'll review up front, what is the dust collection system? What information do we know about the dust? What information do we have to kind of make the choices? And then they will give guidance on if they think that's adequate or not. The challenge with a design DHA is a lot of customers think that it's like, okay, great, I checked the box, I did my design DHA up front. But what they are missing as part of that is then once the system is up and installed and operational, if you assumed a dust value, say we assumed a KST of less than 200 for our design, now once you have the dust, it's really important that you go and get your dust tested to confirm that the assumptions you made upstream are appropriate. If you get your dust tested and it's, a KST of 150, great. You may not need to make modifications to your system, but it's that part of once it's installed and operational, are the choices you made at the design phase appropriate, or do you need to go back and modify something as part of your process? So that's the follow-up. So there's design DHAs. There's a lot of companies out there that will do them. Ask those companies first, knowing so they don't show up thinking there's a building, but then you got to do the follow-up once it's also done. And that would be the responsibility of the process owner to do that part.
So Chrissy, next question, and kind of a similar topic, but if there's an existing facility that relocates an existing dust collector, the question is, does NFPA 660 apply to the new facility? But I kind of suspect it'll be a similar answer. Now you got to update the DHA, right?
Yes, you do have to update the DHA. The other thing that's probably not going to be the same are the local codes. So if you move it into states, sometimes states will have local codes that are often more strict than the actual NFPA code or the whatever the original standard was. And so it's really important to pay attention to your local codes. I know there's a few states out there where the mechanical code requires if it's adopted, right, requires sprinkler ports in the ducting, right? That might be something that not all states have adopted, but it's something that if you move to a different state, again, you want to look at, here's the system, here's how it was designed, but given the new location, what do we have to change or update or modify?
So we are at time, Chrissy. Are you able to stay maybe an extra 5 minutes? Is that okay? Or do you need to get going?
I can stay like 2.
Okay. All right. So this will probably be our last question. And for anyone that didn't get their question answered, we'll make sure and reach out to make sure that you got it answered. For hazardous location classifications, what data inputs are needed and what roles are accountable for supplying and validating the assumptions about dust presence, like likelihood quantities and operating scenarios? We've got a hazardous location classification.
Yeah, that's a great question. So as part of your DHA, there's actually going to be DHA companies that kind of will specialize in this aspect of it. And so they will go out and kind of assess the room. Those hazardous area location classifications are significantly easier to do once the process is operational, because you can kind of stand in the room and you can kind of get a visual look. A lot of times they'll make judgments on it. That's not something that's part of our scope, so I don't know a lot about what goes into it, but it is something that I would work with, like your local EHS team at the facility, or find like a qualified electrical engineer or someone who might know more about determining what goes into that, and I would work with them. In all of the NFPA scopes, there are going to be kind of specialists that know their stuff, right? So we are leaders in filtration and dust collection technology. I don't consider myself an expert in explosion vent design or isolation, components. I'm knowledgeable, but I will often refer to those manufacturers as well, those industry experts on electrical, for their guidance, because it takes a team effort. And so I think, like the hazardous classification, you want to make sure you're working with someone who is knowledgeable of the subject and then get their advice so that you're not getting the wrong information.
Thank you, Chrissy. Great job. Thank you so much. And again, for those of you that had some questions that didn't get answered, we'll make sure and reach out separately to make sure that we're able to answer those questions for you. So thanks
Absolutely.
for everyone for your time today. John, did you have anything else?
Nope, that's it. Thank you.
Thanks,
right,
everybody.
thank
Have a
you.
great day. Thanks again, Chrissy.